Hi guys, today we are going to deal with a new chapter, that is chapter 10 in your science textbook, Gravitation. So you must have learned in the previous classes about the motion of the objects or the movement of the objects, and you have learned also that force is being applied on an object for the motion or the movement of that object. There are different types of forces that you can see around. And there is a special kind of force that the earth shows that attracts everything towards its center, and that is called as the gravitational force. For example,
when a fruit falls from a tree, it comes down. If you throw a ball up in the air, it falls back to the ground.
we have seen different examples, right? Now, so everything falls back to the earth because the earth shows something called as gravitational force. Now, there was a scientist called as Sir Isaac Newton, and you must have been familiar with his story. One day he was going out and he sat under an apple tree, and suddenly one apple fell on his head. And he was thinking why the apple fell downwards. Why didn't it go upwards or sideways or anything like that? He kept on thinking and finally he understood that the earth is showing some kind of attractional force towards its center, and that is how he discovered the gravitational force. Now you have heard or you must have learned in the smaller classes that moon rotates around the earth, right? So if the earth shows some sort of gravitational force, then the moon should also have come and fallen on the earth's surface, right? But it is not happening. Still the moon is rotating around the earth. Now you must be wondering what kind of force is that? We'll see that in another example.
Take a piece of thread. Tie a small stone at one end. Hold the other end of the thread and whirl it round. Note the movement of the stone.
So now you have observed that the stone moves in a circular direction, right? So as the stone moves, it changes the direction. And as it changes the direction, the velocity or the speed of the stone also changes. Now, you must have understood that there is a force that helps the stone to go in a circular motion, and there is a force that helps to connect it to the center. That force is called as centripetal force. Now we'll start with a new topic, that is the universal law of motion. So you have learned about force, right? Gravitational force. So every object in the universe attract each other. Okay, so there is a force that is taking place between these two objects. So that is, first let me introduce a formula and then you can develop the definition for the universal law of motion. So the formula is F is equal to G into M the whole divided by D square. I'll try to explain it with a small figure. So these are two objects, that is object A and object B. And this object A has got mass m and this object B has got small m. Its mass is small m and the distance between these two objects is denoted by d, okay, or d square. Now, when we calculate the force is directly proportional to the product of mass A and mass B. Product means we multiply the masses. So the mass of the A is big M and the mass of the B is small m. So we multiply the masses, M into M. So F is directly proportional to the product of the masses of two objects, and F is indirectly proportional to the distance square. So this is the formula. So universal law of motion can be denoted as the force is directly proportional to the product of the masses and indirectly proportional to the square of the distance. So now you must be wondering what this G is. G is a universal gravitational constant and the value is 6.673 into 10 raised to minus 11 Nm square kg square. So this is a constant value. It doesn't change. So when you calculate when the mass of two objects is given and the distance is given, you can easily calculate the force that is taking place or the force that helps them to attract to each other. So the force is directly proportional to the mass of or the product of the masses and indirectly proportional to the distance between them or indirectly proportional to the square of the distance between them. So this is the formula for the universal law of motion. And we are winding up for today's session. Thank you.